In this video, we are going to talk about the slopes of parallel and perpendicular lines. Now, in order to talk about parallel and perpendicular lines, though, we need to make sure that we understand what they are. So for that, please take a look at my crudely drawn pictures down below. We'll start with the picture on the left. This picture shows two up and down lines. If they were perfectly drawn, they would be exactly the same, perfectly up and down, and we would call these parallel lines, because if we were to extend these lines out forever, they would never intersect each other, and that is what parallel lines are all about. They will never intersect. And they don't have to be always up and down. You could have parallel lines that are left to right or diagonal. As long as they never touch each other, they never intersect, they never get closer or farther apart, they stay exactly that distance apart their entire existence, they would be considered parallel lines. Perpendicular lines, as we can see, are not parallel. They do intersect each other. We have a line going left to right, and we have a line going up and down. What's special about their intersection, though, is the fact that they create a right angle, a 90-degree angle when they intersect each other. And this is what makes perpendicular lines perpendicular. As a matter of fact, perpendicular means intersecting at a 90-degree angle, or a right angle. So, perpendicular lines cross each other at a 90-degree angle. Parallel lines never cross each other, and they never get closer or farther apart. They always stay the same distance apart. Now that we know what parallel and perpendicular lines are, let's clean off this page and talk about their slopes. So here we have two parallel lines, and we're going to talk about their slopes. What we need to remember about parallel slopes is that the slopes of the lines are exactly the same, and that's important, so let's write that down here. Slopes of parallel lines are exactly the same. So if this slope would be, let's just say 1 over 2, then the bottom parallel line, the bottom line, would have 1 over 2 as their slope as well. And that makes sense. We said that they will never intersect each other, they'll never cross, and they never get closer or farther apart. Well, slope determines how steep it is. How is it changing from left to right? And for that to happen, for them to never get closer or never get farther apart, they have to be changing at the same rate. They have to be changing the same amount. If this one goes up 1 over 2, this one has to go up 1 over 2. Otherwise, they would not be parallel. They would eventually get closer and closer and closer until they intersected and they would cross. And then the line that was on the bottom would suddenly be on the top, and they would no longer be parallel slopes or parallel lines. So, in a parallel line, both of them have exactly the same slopes. And if you're asked to decide whether or not two lines are parallel, all you have to do is discover their slope. You know a slope formula, where if you have 2 points, the slope formula is y2 minus y1 over x2 minus x1. If you take 2 points on both of the lines, and they don't have to be straight in line with each other, if you take 2 points here and get a slope, and 2 points there and get a slope, if they are parallel, their slopes will match up exactly. Not close, not just about, exactly. Well, that's about all there is for parallel slopes. Let's talk about perpendicular slopes now. Perpendicular slopes are different than parallel slopes, mainly because, as we see from our picture here, these lines definitely cross each other. And remember, that whole point of being perpendicular means they cross at a 90-degree angle. They make a right angle here. Because as long as two lines have different slopes, let's say I have y equals 2x and y equals 3x, their slopes are different. This has a slope of 2, this has a slope of 3. These two lines will cross each other at some point throughout their existence. But they won't make a right angle. Perpendicular slopes have a special relationship. So as long as the slopes are different, they're going to cross. But if we want them to be perpendicular, they have to have what is called opposite reciprocal slopes. So let me write that down. That's an important part here. Perpendicular slopes are opposite reciprocals of each other. And what does this mean? Because we've got some big words in here, opposite and reciprocal. Opposite means if one was positive, the other has to be negative. Or if one was negative, the other has to be positive. And reciprocal means that it is the inverse. So if we had, let's say, 2/3, the reciprocal would be 3/2. We just took that fraction and we flipped it. We took the inverse of it. So, opposite reciprocals. Let's say, let's get a better picture here. I've got this line. I have a line like this, and I have a line like that. And they just so happen to make a right angle. So since I know that they make a right angle, I know they are perpendicular with each other. And if I know the slope of one, I can figure out the slope of the other. Let's say the slope of our rising line, this line right here, let's say the slope of this line is y equals 3/4 x. The slope says we're going up 3/4. We're positive, so we're going up. Now, and actually let's make this line blue so we know which one we're talking about. I know that they are perpendicular. They're making that right angle. If I want to get the slope of this line, all I need to know is the slope of the other line, which is 3/4, and I'm going to take the opposite reciprocal. Opposite. This is a positive slope, so here we are going to have a negative slope. Reciprocal. I'm going to take that fraction, 3/4, and I'm going to flip it. So instead of being 3/4, it is now 4/3 x, and there we have it. These two lines are perpendicular to each other, and it's all based around that slope. So we have negative 4/3 x here, and we have positive 3/4 x there. We have our perpendicular slopes. And you might be saying, well, what if we have a y-intercept? So instead of 3/4 x, we have 3/4 x minus 4. Well, that y-intercept, that y-intercept is not going to affect our perpendicularness. Only the slopes affect that. Now we could figure out what the y-intercept is, and we'll do that in a moment, but it is not very important right now. Alright, so we've talked about parallel slopes, we've talked about perpendicular slopes. Let's try one more example with perpendicular slopes where we're trying to get the whole thing here. We're trying to figure out what our original equation is and what our new equation would be to give us two perpendicular lines. Let's take a look. Now this is an example of a question you might see on homework when we're dealing with the slopes of parallel and perpendicular lines. Let's say that we have the line y equals 3x minus 1, and we want to create the equation for a new line. And that new line wants to be perpendicular to the original, so they want to create a 90-degree angle when they cross, and we want it to go through this point. Well, this is going to take two things in order for us to get it right. One, we need to know the slope. We need our slope. Two, we need to remember point-slope form. And if you don't remember point-slope form, I have a video on point-slope form that you can use as a review. Take a look in my video archive. So, first thing we need to do is get the slope of our new line. And to do that, we need to look at the slope of the original line. Here, the slope is 3, or we could think of it as 3 over 1. So our new slope has to be the opposite reciprocal. Opposite reciprocal. If the original slope is positive, the new slope is going to be negative. Since the original slope was 3 over 1, the new slope, taking the reciprocal, is going to be 1 over 3. So our new slope is negative 1/3. Now that we have the slope, we also have a point. So point-slope form is going to be our best friend here. Remember, point-slope form is y minus y1 equals m times x minus x1, where m is our slope and y1 and x1 are the pieces of our coordinate we want the line to pass through. So if I put this together, I get y minus 2 equals negative 1/3 times x minus 3. Now, if they are not picky about what form you put it in, you could be done right now. This is the equation of a line that is going to be perpendicular to the original, and it's going to go through that point. If the directions say that we need to put it into slope-intercept form, just like the original though, we got to do a little bit of work. We're going to have to get y alone, so I'm going to add 2 to both sides. That's going to give me y equals negative 1/3 times x minus 3 plus 2. And then I'm going to have to distribute the negative 1/3 inside. So that is going to give me y equals negative 1/3 x plus 1, since 3 times a third is just 1, and negative times a negative is a positive. And then we can't forget the plus 2 on the outside. So in the end, we get y equals negative 1/3 x plus 3. And if we were to graph these two lines, okay, we have our original line up here, y equals 3x minus 1, and we have our new line down here. If we were to graph these two, they would cross each other at a perfect 90-degree angle. And there we have it. I hope you found this video on slopes of parallel and perpendicular lines useful. Good luck.